Good morning. Next point is mutarotation. Mutarotation. Look at here. What is mutarotation? In the case of most reducing sugars, what do you mean by reducing sugars? We know that in glucose there is a CHO group, and we have studied that CHO group. For example, with the tolerance reagent, CHO group reduces tolerance reagent to metallic silver. So our glucose is containing CHO group. CHO group is a reducing group, or we can say that these are reducing sugars. Due to the presence of CHO group, it can reduce silver nitrate, that means tolerance reagent, filling solution, etc. And they themselves will be oxidized. So that's why they are called reducing sugars. So in the case of most reducing sugars, like our glucose, due to the presence of CHO group can reduce tolerance reagent, filling solutions, etc. Therefore, they are known as reducing sugars. It is seen that on dissolving in water, what will happen? Their optical rotatory power gradually change until a constant value is reached. This phenomenon is called mutarotation. That means our reducing sugars like glucose is dissolved in water. What will happen? We know that they have they are optically active compounds because they have chiral carbon. So their rotatory power, say, look at here, when these reducing sugars are dissolved in water, their optical rotatory power gradually change, optical rotation gradually change until a constant value is reached. This phenomenon is called mutarotation. Let us discuss mutarotation with an example. A freshly prepared solution of alpha D glucose shows a specific rotation of plus 112.2 degree. What is the specific rotation of alpha D glucose? 112.2 degree. This is the specific rotation of alpha D glucose. This value gradually falls because we are preparing a solution. That means when we dissolve alpha D glucose in water, its optical rotation decreases from plus 112.2 degree, that means gradually falls until it reaches plus 52.7 degree. So when we dissolve alpha D glucose in water, its optical rotation decreases from 112.2 degree to plus 52.7 degree. Similarly, and after that what will happen, and then remains steady. This 52.7, after that it will remain steady as a 52.7 degree only. On the other hand, when crystals of beta D glucose, here it is alpha D glucose, beta D glucose are dissolved in water, their specific rotation gradually rises from the initial plus 18.7 to a steady value of 52.7. That means in the case of beta D glucose, its actual rotation is what is the rotatory power? 18.7 degree. But when you dissolve in water, we can see that its optical rotation gradually rises from 18.7 to our steady value of 52.7. This is called a mutarotation. That means in a very simple way we can see that the optical rotation of alpha D glucose decreases from plus 112.2 degree to 52.7, and similarly in the case of beta D glucose, its optical rotatory power increases from 18.7 to 52.7 and remains steady. This phenomenon is called mutarotation. What is the reason for this mutarotation? What is the reason for mutarotation? Look at here. Mutarotation has been explained by assuming that in aqueous solution, either anomeric forms gets converted into the other through the open chain form. That means when we dissolve our reducing sugar in water, when we dissolve our reducing sugar in water, one anomeric form, that means we know that there are two anomeric forms for glucose, alpha D glucose and beta D glucose. When we dissolve in water, what will happen? One anomeric form, say example, alpha D glucose will gradually convert to beta D glucose, and beta D glucose will gradually convert to alpha D glucose, and this conversion is taking place through the open chain form of D-glucose. That is the reason. So we are coming back. Mutarotation has been explained by assuming that in aqueous solution, when you dissolve in water, either anomeric forms, that means alpha D-glucose and beta D-glucose, gets converted into the other through the open chain form. A state of equilibrium between them is finally reached. As I told you, one form is alpha form is converting to beta form is converting to alpha form, and there will be an equilibrium between these two forms. But during this conversion, one form first will be converted to open chain, and that open chain is converting to other. Okay. Between them finally reach, so that the specific rotation attains a constant value. So look at here, which form is this one? Alpha D glucose. Alpha D glucose is this one. So when you dissolve in water, what will happen? This alpha D glucose will convert to, this is beta D glucose. It will change into beta D glucose, and beta D glucose will be converted to alpha D glucose through open chain form. This is the open chain form. This is our reducing sugar form. Aldehyde group is there. This is our open chain form. So once again, the reason for mutarotation, or why there is a constant value is attaining, the reason is that one epimeric form or anomeric form, say alpha D glucose, is converting to beta D glucose through open chain form. That means there will be an equilibrium between alpha D glucose and beta D glucose, and equilibrium between their open chain form. So there will be an equilibrium between alpha D glucose and the open chain form. Then there is an equilibrium between open chain form and beta D glucose. That means there will be an equilibrium between alpha D glucose, beta D glucose with their open chain form when we dissolve the reducing sugar in water. Understood? So what is happening? There will be an equilibrium between these three forms. These three forms, which are the three forms? The two anomeric form and their open chain. There will be an equilibrium between all these three. Therefore, what will happen? We can see that this alpha D glucose mutarotation was plus 112.2. When it is gradually changing to beta D glucose, their rotation power will decrease, and here you can see that beta D glucose plus 18, that will change into alpha D glucose. Its rotatory power is increasing, and finally they will attain a constant value of 52.7 degree. This is the assumption for mutarotation. Okay, thank you.